Okay, today we consider a minimum spanning tree and an algorithm to find one. But before we do that, let's just think about what a minimum spanning tree is. And to do that, we're going to have a look at what a spanning tree is. So let's have a look at a small example, first of all, to explain what a spanning tree is. So here I have a network. It's a complete network, but it doesn't have to be. Given that it's connected, that is, you can get from one node to any other node by traveling along arcs, then there exists a tree which is made up of some of these arcs, which spans the network. It gets to every node in the network. So an example of a spanning tree of this network is this one. This is a tree because it's got 4 nodes and 3 arcs. So it's a tree, which is connected. So it's a tree. Also, we can see there's no cycles. Okay, if I want to go back to a node, I have to go back along an arc I've already used. It spans the network, so I can get from any node to any other node. So I can get from D to C by traveling through B, or I can get from A to D by traveling through B, or I can get from B to C, or whatever. Okay, so this is a spanning tree. This is not a spanning tree because it doesn't span the network. I can't get to node C. So even though we've got 4 nodes and 3 arcs, it is not a spanning tree because, first of all, I can't get to node C, and second of all, it's not a tree because we have a cycle here. Okay, so it can't be a tree anyway. So that is not a spanning tree. This one is a spanning tree. A couple more examples. Here, we've got 4 nodes and 4 arcs, therefore there has to be a cycle. And we can see there's a cycle if I go around here. So therefore that cannot be a spanning tree because it's not a tree. This one is a spanning tree. Again, actually similar layout to that one, isn't it? I've got 1 node connected to the other 3 by arcs, and it spans the network. So that is also a spanning tree. Okay. Now the minimum spanning tree, or a minimum spanning tree in some cases, is the spanning tree which has the minimum total weighting of the arcs that are chosen. So for example, this one here has a total weighting of 16. So we say that that spanning tree has a weight of 16. This spanning tree has a weight of 18. 7 plus 4 is 18. Neither of those are the minimum spanning tree for this network. And we're going to look at 2 algorithms on this course, one in this video and one in the next video, which find the minimum spanning tree of a network. If you're interested, you can spot this by inspection fairly quickly. But if you're interested, the minimum spanning tree is actually this tree here, and it's got a total weighting of 13. Okay, you're not going to find a tree which spans the network, which has a smaller weighting than that. Okay, so let's apply one of the algorithms to a network. So the first algorithm, which is what we're going to look at in today's video, is called Kruskal's algorithm, and it's quite simple. All we're going to do is we're going to keep selecting the smallest arc or the shortest arc without creating a cycle. Kruskal's algorithm is what is referred to as a greedy algorithm, and that is because it keeps looking at the entire network and then keeps grabbing the best arc for it. Okay, it is not heuristic. It will give the optimal solution, and the other algorithm we look at is Prim's. That also will give an optimal solution, if not the optimal, if it's the only one. Okay, so keep selecting the arcs with the smallest weighting without creating a cycle, and then once you get to n-1 arcs, stop. Okay, so in this network we've got 1, 2, 3, 4, 5, 6, 7, 8 nodes. So 8 nodes. The minimum spanning tree then has to have 7 arcs. Okay, 8 nodes means 7 arcs for the tree. Okay, right, so keep selecting the smallest arc. So the first arc I'm going to select is this one, GH. It's got a length of 1. It's the only one on there, the length of 1, so that must be where I start. And part of the algorithm is just illustrating the order in which I'm choosing the arcs. So I'm just going to make a list down the page here, which says which order I'm choosing the arcs, just to demonstrate that I am following the algorithm correctly. Okay. Right, back to the whole network. I look at the whole network, not just my tree, which is currently this branch over here. I look at the whole network and I choose the smallest arc that doesn't create a cycle. So that's going to be this length here. It's the only 2 in the network. So BE is the next one that's chosen. There's no more 2s. Let's have a look at 3s. There are 2 3s, and you can choose them in either order. Doesn't actually matter. And then, in fact, in this case, you'll just choose the other one next. So I'm going to choose AB first, just because it's alphabetical, and then I'm going to choose DE next. So now those 2 are part of my tree. And what I'm doing is I'm just scribbling out the arcs which I've chosen so I can see where my tree is. So it makes it easy to decide which to reject. Okay, so that's all the 3s. Now look for the 4s. There is 1 4, BD. However, if I choose that, that's going to give me a cycle, which means that will break my tree. It won't be a tree anymore. So I'm not going to choose that, but I must evidence that I've rejected it at this point. So I'm just going to pop down BD here. I'm going to put a little cross there just to illustrate that I am rejecting this arc. Okay, so that's been rejected. No more 4s. Okay, choose a 5. So the 2 5s here. I've got a choice again, but this time, unlike the 3s, when I chose one and then I chose the other, I'm actually going to choose one of them and then reject the other, because if I choose both of them, I'm going to end up with a cycle around here, and I don't want a cycle. As for which you choose, it doesn't matter. All this is going to do is it's going to bring my 2 pieces of tree together. So I'm just going to choose, let's go with DH. DH, that's got a length of 5, and then the other one, which is EG, will be rejected. But you might have that the other way around. So this has now been selected, which means that is now rejected. Okay, so that's all the 5s. Now move to the 6s. There's a 6 here, DG, but that's going to be rejected because that's going to give me a cycle. So DG, I'm rejecting that one. There's a 6 over here, AC. Now that's good because C is not part of my tree, so I'm just going to choose that arc there. So AC gets chosen next. Then the 7s, there's 2 7s, they're both going to be rejected because they're both going to give me some kind of cycle. So I'm going to reject both of those. So BC gets rejected and CD gets rejected. And then 8s, EH gets rejected and FG is accepted. So I'm going to pop FG first. You could have chosen EH first to reject, but in choosing FG, actually that finishes my tree. So I actually just stop there. Add up the total weightings. That's 3, 6, 9, 14, 20, 28. So my total weighting is 28. That is the minimum spanning tree. In this case, it just so happens that the tree is just one long line. It didn't have to be the case. I could have chosen these 2 the other way around, which would have meant that this arc was chosen instead of this one. Might make it a bit more of an interesting tree rather than a straight line, but that is a minimum spanning tree of the network. Okay, you're not going to find a tree which spans the network in a smaller total weighting. All right. Thank you very much for watching. My next video will be on the other algorithm which you need to know, and you do need to be able to follow the correct algorithm upon request. All right, so check that one out. Thank you very much for watching.